Einstein described in a famous work on the electrodynamics of moving bodies a special consequence of his principle of relativity, which was later called the twin paradox. Paradox is here really nothing. He merely showed that a clock at the equator would be slower than a clock of the same design at the Earth's pole. Basically it was a theorem. Einstein's proof was more intuitive. For more detailed analysis, he later resorted to general relativity. Time dilation in special relativity is mutual. If two observers move relative to each other, each of them can claim that the other observer's clock is slower than his own. This seems obvious when one thinks about relativity. But then Einstein's theorem comes out.
If one of two synchronous clocks at A is moved in a closed curve with constant velocity until it returns to A, then by the clock which has remained at rest the traveled clock on its arrival at A will be slow.
The importance of this theorem for the theory of relativity can never be overestimated. First, in this case time dilation becomes reality. Therefore experimental results are interpreted according to this scheme. For example, the decay of fast muons. In the thought one imagines an observer standing near the storage ring. After each orbit, the particles return to this observer over and over again and so countless times. In this way, real deceleration of decay occurs despite mutual time dilation. The closed routes are therefore an important part of the experiments. Then nature seems to function exactly according to relativistic laws and there is no conflict with the mutuality of time dilation. In reality, however, it is easier, that is even in the case when two observers move only relative to each other. Except for mutual time dilation nothing would be expected here. But in 1938 the researchers Ives and Stilwell were able to observe real time dilation even under these conditions. They measured the oscillations of the rapidly moving hydrogen atoms. The frequency of these oscillations was smaller than that of the resting atoms. Oscillating atoms can be thought of as ticking clocks. In other words, moving clocks ticked rare, so they went slower. It was undoubtedly time dilation. This experiment is presented as a confirmation of special theory of relativity. But here the time dilation was noted immediately and in one place during the flyby. The experiment of Ives and Stilwell therefore proves the ether theory, where time dilation is always real.